Happy July, space fans! We're conversing a bit later into this month about something you really shouldn't see here. You should see it on the biggest, highest resolution screen you can get access to. For us in Danville, that's the Dome at the Danville Science Center. So, go there and ask, and I'll show it to you. But you should at least know about it, and we'll get there. First, let's transport outside of the Dome to discover what's left of this month's sky. It's Tuesday, June 21st, a bit before 9:30 p.m., and in the southwest lies a first quarter moon increasing in light from last Tuesday's new moon. The moon is 7 days old. Further in the west is the second brightest object in tonight's sky, the second planet from the sun, Venus. Venus reached lunar conjunction this past Friday, and since, the two have increased their separation. In fact, if you don't look far enough west from tonight's moon, you may mistake bright Spica, the brightest star in Virgo the Maiden, for the planet. The moon is just barely within the bound of Virgo's space. July ends next week with a good chance of spotting meteors. The Piscis Austronid shower peaks next Wednesday. The southern Sigma Aquarid and Alpha Capricornid peak next Thursday. And the Perseids are getting ramped up with a peak just a few weeks away. Today, we are not discussing any of that. Instead, we are discovering a region of space that lies between Centaurus the Centaur and Lupus the Wolf. A region that you really should see on the biggest screen you have access to. A region that in order to appreciate, we must first talk about Chile. Meet the Vera C. Rubin Observatory, a joint effort between the National Science Foundation and the United States Department of Energy, located in the South American country of Chile. Why Chile? Altitude, seclusion, and humidity. The Rubin Observatory is 8,800 feet above sea level on the El Peñón Peak of Cerro Mountain in northern Chile, placing it closer to the objects of its observation, the sky. The base facility for the observatory is 62 miles away. Rubin need not worry about light pollution from other buildings or cars. Chilean air is very dry. Clouds need moisture to form, so less moisture equals more clear sky to observe. Rubin opened in June 2025 and released images to the public earlier this month. Images so big that they need to be seen on the biggest screen available to really appreciate. That's because Rubin houses the largest digital camera ever built. Rubin uses the wide-field reflecting Simony Survey telescope to reflect the light of stars, galaxies, and more into its 3.2 gigapixel digital camera. A camera that is roughly as tall as an adult human. Rubin spends 30 seconds recording the image to its 189 CCDs, moves for 10 seconds, then repeats the process at the next location over and over again. It takes the observatory only 3 nights to map the entire sky, each night delivering 20 terabytes of data. Rubin will continue to do so for the next 10 years, resulting in the biggest, highest resolution stop-motion video of the universe possible. The observatory is anticipated to catalog millions of supernovae, 5 million new asteroids, and 20 billion galaxies. Currently, the highest resolution iPhone has a 49 megapixel camera. Rubin's camera takes pictures at 3,200 megapixels. To view an image of that quality full size would take 400 ultra high definition TVs. I don't have 400 ultra high definition TVs, but I do have something that comes close. Don't view this picture, titled An Ocean of Stars, on your phone. Come to the Danville Science Center or your local giant screen planetarium and tell them, show me that big picture. I'll be here, waiting. School starts in just a few weeks. Discover even more space facts to impress your friends when we return next month for further discussion, the second Tuesday of August, August the 12th, when there'll be a total solar eclipse that we can't see. More on that then. Talk to you next month. Thank you for watching and keep discovering.